Yes, welcome back. So in the previous videos we have been discussed about a single point cutting tool. So and we have been discussed what are some of the major parts of the single point cutting tool. As you know that single point cutting tool means only we will be having one cutting edge. So in this video we are going to say about the cutting tool geometry, that is single point cutting tool complete geometry we are going to discuss, and we are going to discuss about the theory of a chip formation, how the chips will be formed during the machining process, along with the diagrams we're going to discuss about this two topics in this video. So when we come to the cutting point cutting tool geometry, so first we'll see the diagram, then we'll come to the theory part. So this is about a single point cutting tool geometry, where you can able to see this single point cutting tool geometry. So in the previous video when we have discussed about the single point cutting tool, so we have seen about the complete the tool and along with the nomenclature. So here we have been discriminated to the each part and each section in the tool. So that is the reason what we call it as a complete discrimination of single point cutting tool geometry. So first you can able to see this is what we called as a shank. As we know that the shank is used to hold the tool post. The shank will hold by the tool post rigidly in order to reduce the vibrations and to give a good surface finish to the workpiece. You can able to see this nose, face nose radius. The face nose radius is nothing but what this portion what we call as a nose, or this is what we call as a cutting edge. So the purpose of the cutting edge is with the help of the cutting edge only we are going to remove the excess material and the workpiece in order to yeah, remove the excess material. So the cutting edge only allows the material to allows the tool to remove the excess material and the workpiece. So this is the angle between these two what we call as an end cutting edge angle, and this is what we call as an nose, and this portion what we call as an cutting edge. As you know that these are the shank, and this angle what we call as a side cutting edge angle, and this is what we called as a side rake angle, and this is what we called as uh, the angle between these two portion what we called a lip angle, and this what we called as a back rack angle, and the angle between this is what we called as an end clearance angle. The angle between these two what we called as an end relief angle, and this angle between these two what we called as a side relief angle between these two what we called as a side rake angle. So these are some of the major nomenclature of the single point tool geometry. So this is about a single point cutting tool, but we're going to clearly discriminate all the parts, and we're going to in depthly we're going to study about the single point tool geometry. This is what we called as a single point tool geometry, right? So now we're going to see about the cutting tool geometry. So the end relief angle is nothing but the end relief angle is defined as angle between the portion of the end flank immediately so below the cutting edge and the line perpendicular to the base of the tool, what the measured we called as a right angles to the flank. So side relief angle is nothing but what we called as a side relief angle is, so side right angle is the angle between the portion of side flank immediately below the side edge and the line perpendicular to the base of the tool, what we go measured or what we have seen, that will be the right angles to the that's other side of that portion. So the end cutting edge angle is nothing but the end cutting edge angle is angle between the end cutting edge and a line to the perpendicular to the shank of the tool. So the side cutting means side cutting edge angle is angle between the straight cutting edge and the side tool of the shank, what we have been seen in the this single point tool geometry. So these are all are the different types of nomenclature or a different nomenclature. These are all has been used in the single point tool geometry to form one complete tool. So this is what we called as a single point cutting tool geometry, where all this nomenclature will be used in all the type of single point cutting tool. So as you know, the difference between the single point and a multi-point tool is nothing but in the single point we'll be having only one cutting edge, and in the multi-point we'll be having more than one cutting edge. So the main is the cutting edge only helps or uses the cutting edge only in order to remove the excess material on the workpiece. So that is what we called as a single point tool. And always we should able to remember that the tool should be harder than the material. Otherwise the cutting force cannot able to withstand by the tool, that causes the breakage of the tool, and the surface finish will be also it will be not good. So that is the reason. So whenever you're going to select any type of tool, whether it might be a single point or whether it might be a multi point, so mainly we should able to know about the type of material, which type of material is a workpiece. So based on that selection of the material, based on that we should select the type of tool that has to be used for that particular cutting or an forming process. And this is what we have been saying. Shank is nothing but, as we have been discussed this. So next is about the theory of a chip formation. What is the theory of a chip formation? Chips is nothing but, as we know, that very small portions of materials will be removed in this workpiece whenever machining process takes place. So always the excess material will be removed in the different types of chips. So whether it might be a continuous chips, or whether it might be a breaking chips, or whether it might be any other type of chips that will be formed. So what we are going to, how the theory of chip formation is nothing but, where you can able to see. So this is normally, this is in a workpiece where I am going to place the, can able to see this as a tool, where we are going to start removing the excess material and the chip flow direction. See that you can able to see the flow of the chips in a direction, that is how the flow of the chips in the different direction, that depends upon whether it might be an orthogonal cutting or oblique cutting. But generally, what is the function of the chip formation is, when we start removing the excess material on the workpiece, so the small amount of material will starts, or the small amount of materials will start into the coming out because of that workpiece material. So this is what we have been seen or identify in the chip, chip formation. So it has been classified into majorly, when we discuss about the theory of chip formation, majorly the tool has been classified, sorry, workpiece has been classified into two categories. One is secondary shear zone, primary shear zone, and a secondary shear zone. See this portion below the axis, what we call this as in a secondary, this portion what we can able to see between the tool and the chip formation when takes place, that is what we call it as in a, in this particular direction we call it as in a secondary shear zone. So in this portion what we can able to see, in this direction when the chip starts moving, what we call it as a primary shear zone. So shear zone is shearing is nothing but where excess material starts removing, or the material starts removing in the form of chips. This is what we call it as a primary zone and a secondary zone. So the angle between this flow of direction of chip and the workpiece, what we call it as an effective pi. So this is what the angle that is formed between or the process taking place between these two when we start removing the excess material. So now we can able to see this. So it is placed between the primary shear zone and a secondary shear zone, where in this we can able to see the chips formation of the flow of the chip direction and the tool which we have been placed here. When we start removing the tool from the beginning of the workpiece, so some excess material that forms the excess material will be removed in the form of, or in the types of chips, where the flow of chips will be in this particular direction which comes out. So here it has been classified into primary zone and then a secondary zone. The angle between this chip flow direction and the workpiece, what is that is what we call it as an effective pi. So now we see about the theory. The formation of chip in a metal cutting is the above figure what we have been seeing. It's a geometry of a dimensional chip formation. When the cutting tool is forced to move against the workpiece, the tool exerts a compressive force on the workpiece. So when we go into force against the work tool, so the tool will force to move against the workpiece. That force is what we applied, or what the tool exert will be compressive force on the workpiece. So the material of the workpiece is stressed behind the yield point, causing to the deform. That is what we call it as a plastic layer and the shear off. So the plastic flow takes place in localized region. That is what we call it as a shear plane. So the sheared portion of the metal begins to flow along the cutting face in the form of small pieces. That is what we call it as a chips. So this is how the formation of chips will be taking in a metal cutting. So only the compressive forces will be exerted during the work. A tool exerts the compressive force on the workpiece. So the sheared portion, or the small portions, what we call that metal begins to flow along the cutting tool. So in the form of a small chips, small pieces, that is what we call it as a chips. So this is about a theory of a chip formation. Yes, thank you.